Thank you, everybody. Yes, I'm Marcus Jones. I work in TRL's Sustainable Mobility Group, and we're doing a number of projects that relate to autonomous vehicles, integrated transport, and transport interchange. So what I wanted to talk to you today about, and I think an awful lot of the issues have already been raised very well beforehand, so thank you very much, is we know a lot about integrated transport, and there's a lot of talk about autonomous vehicles, but where will they fit in to the bigger picture? So I thought I'd start off by saying, what do we mean by integrated transport? There's lots of different definitions in the transport literature, and we probably all have an idea of what we think it means. It clearly implies it's multimodal travel, but that doesn't necessarily mean that every journey is multimodal, rather there is a choice of modes available. We know about shared information, online journey planners, apps, ticketing systems like Oyster that are multimodal. And the key to all that is that the different modes cooperate with each other rather than competing. And I'll come back to that in a bit. Key to all this is that there's choices to the user. So the user, faced with a particular journey they might need to make, doesn't have to think, well, my default is I will drive because I can't really imagine any other way of doing it, that there will be other choices, you'll see other people making choices, and you'll be able to use them. And those choices will be made easy for you to find out about and to have access to. They'll be user-friendly, so rather than having to fight through a million different websites or phone systems or whatever, it'll be obvious to you what ticket you need, what service you need, and what's available. Crucially, accessible, so people with different, people with impaired vision, people who have difficulty getting about. Integrated transport has to include accessibility for it to be integrated. And, linking onto that then, we see integrated transport as forming part of wider sustainability and social justice. So integrated transport has to be sustainable transport. Integrated transport has to meet our needs for carbon reduction and the points that Ray has just mentioned. Some modes are clearly already inherently multimodal, but that does not mean that they are necessarily well integrated. I put a chart here showing the access mode for a number of different stations that we looked at in a different study. I just wanted to draw out a few points on that. First of all, that even in stations that are perceived to be parkway-type stations or one where the car park is very visible, that walking is actually the main access mode for most railway stations. Interchange with buses, however, is actually quite low in most locations, and that shows that there's a difficulty there, that there's an opportunity that's being missed. Car parking is often overstated. It's clearly very visible. It brings in revenue to the operators. It takes up a lot of space, and it is, at a lot of stations, a limit on growth because a lot more people would like to park there. The car parks are too small, so they need further investment to grow them. But what often gets forgotten about with car access is that at many stations, people being dropped off and picked up are just as numerous, or often more, than the people who park their car and stay there. The people who are being dropped off and picked up need far less space, but a lot of station forecourts, when you look at them, are very complicated, they're very congested, they're very difficult. And when we start talking about where autonomous vehicles would fit into this, clearly the balance will shift. We need more space for easy pick-up and drop-off, and less space needed for physical parking. There has, however, been, in the last few years, one very good example of a success story in integrated transport, and that is using bicycles to access stations. Following a lot of investment from the government and through rail operators, the amount of cycle parking at station has more than doubled since 2010, and there's been a corresponding very significant 70% increase, probably more than that by now actually, because that's a couple of years out of date now, increase in the number of cycles parked. And the charts there show, I'm afraid my eyesight isn't good enough to point out to you the legends, but you can see that the numbers who are taking their bikes and taking their bikes to the stations and parking them, the people taking their bikes to the stations and going on the train. And what there has been a steady shift, actually, just quite recently, with more and more people leaving their bikes at the station and proportionately fewer taking them on the train, and that's partly because of restrictions in rail operators, but partly because simply the facilities at the station are much better than they used to be. So why isn't there more integrated transport? What are the barriers to it? One point is actually from the user's perspective, interchange is difficult, changing modes is difficult. In transport modelling and terminology, we sometimes refer to the interchange penalty, which is summarised by that bar chart, where on the x-axis, that shows, say, a journey where you catch a bus, you go on the bus, you go to the station, and you catch a train. So along the x-axis is the time spent in that journey. But we have another axis, we have the y-axis, which I've called here the value of time, which is how transport economists would see it, and that is the value that will be attached to it, that the user would attach to saving time. Another way of looking at it would be that's the nuisance value of that time. It's a measure of the inconvenience to the transport user. So the higher that column, the higher is their perceived value of time. So that might mean that the less comfortable they are, the less secure they feel, or also the more uncertain they are about whether, for example, they'll meet their connection. So if we look at a typical journey involving a bus to a station, you stand at the bus stop. There's often very poor quality information at a bus stop. You can't be sure, am I in the right place? Will the bus turn up? Will it be late? So your value of time is very high. When the bus turns up, you think, phew, I can relax a little bit. I may still catch my train. But even so, on the bus, it might not be comfortable. The bus may be held up by traffic, so there's still some uncertainty. So your value of time has declined, but it's still higher than when it is on the train, which is further along, because train travel is perceived to be more reliable. Those of us who use the services into Paddington may have felt differently about that recently, but that's generally true. And again, between those two, we have another interchange point where people are waiting. So again, you're less comfortable, you're not sitting, will your train turn up? That's how transport modelers see the world. One conclusion, that is simply to say that in terms of attracting people to make multimodal journeys, you have to think not just about the absolute time of the journey, but the factors that make that journey attractive, the factors that make it comfortable, their perceptions of the reliability. And for a lot of those things, new technology can help here because it can give more information on whether your bus is turning up or not, allowing you to change your journey plans. And again, seeing the role of autonomous vehicles in here, we can see how something that is more predictable, can be easily booked and has a reliable journey time, will help make access and multimodal travel on rail more attractive. There are a number of other barriers that I've mentioned here. So there are regulatory barriers that sometimes prevent operators working together, and particularly with our deregulated bus system in this country. There are funding processes and the policy decisions that lie behind that, and some of that comes down to the way in which transport appraisal and cost-benefit analysis is undertaken in this country, that places a lot of effort on saving small savings in journey times, disproportionately benefits investment in road transport. You also have some perverse outcomes from transport appraisal, where, for example, if a transport initiative leads to fewer people driving, that's less fuel consumed. The revenue gets less fuel duty, and that is counted as a worse cost-benefit analysis because that is counted as a cost to society, even though you have saved a lot of carbon and met your environmental objectives. So there's a lot of questions here that need to be addressed about what actually do we want as a society from transport investment. And there's a final one here, which I will come back to because it has a lot of bearing on what happens with autonomous vehicles, which is competition for road space. People often perceive transport choice as a fairly neutral decision people are able to make between a number of different options, and that they will drive because they prefer to drive, driving is more comfortable. What's often forgotten is that the act of driving, the traffic on the road, the congestion, makes bus travel more unreliable, so it discourages people from using buses, which further reduces that choice. It makes walking and cycling feel dangerous and unattractive, so it reduces those choices. So part of the decisions about making transport more multimodal and integrated is actually restoring some of that balance between the modes and the space and priority that we give to it. I have an example here. According to the highway code, if you are turning off the carriageway into a side road or into a petrol station and you're crossing a pavement or a cycle track, you're actually supposed to give way to pedestrians and cyclists to a crossing. Similarly, going into a side road junctions. That's what the highway code says. Now, how often do you feel comfortable simply walking across a side road without being run over? Probably not very often. And highway design guidance, actually by making the corners highly radiused, as per the drawing on the right, exacerbates the problem because the aim of the designer is to reduce congestion, to reduce delay to the driver, so the driver is encouraged to turn at a pass that makes it difficult for them to see pedestrians and makes it difficult for the pedestrians to see them. That drawing was taken from a document called the Manual for Streets, which actually recommends a quite different approach where we start tightening up the radii and start making the infrastructure support what the highway code tells us and to make the infrastructure reflect the priorities. But we can see two other hideous examples, a row of cyclist dismount signs at trivial side road crossings and the use of lots of barriers. Those are, for the benefit of pedestrians and cyclists, as you can see. So again, the choices that are made there are to maximize vehicular travel. They discourage the alternatives. So the choice is not neutral. Things are starting to change. There has more recently been a move towards recognizing that streets have a function that isn't just about getting people from A to B. There's not simply a transport infrastructure like a railway. That streets are also places where people live, they're places where people work, where they shop, where they pass time. This has been reflected through the Roads Task Force and in a lot of in this, which is Transport for London's Streetscape Design Guidance, which is this idea that we have a matrix. We have a place function, which shows the extent to which people linger, to which the space is useful for where people are living, and a movement function, which represents the importance of it for moving, for transport. And so clearly, a motorway has a very high movement function and no real place function. You'd expect motorised traffic to be prioritised there. Conversely, a town centre, a street outside a school, is predominantly a place function, so therefore we'd expect the traffic, the infrastructure, the capacity to prioritise the people who are there as opposed to vehicles moving the place. This has been a very important development and has come through in cycling infrastructure, in design for guidance. A lot of local authorities are reluctant to adopt it, but nonetheless it is progress. So this is quite an important trend and is leading to a changed approach to the priority that we give to road space. And that's, again, away from, so on the left-hand side, this is a cycle track in Brighton where space was taken off the carriageway and allocated to a Dutch-style cycle track. So that's less space for the motorised traffic, more space for the sustainable mode. The middle shows a photograph of a type of design of roundabout common in the Netherlands that we tested on our test track at TRL, and that gives priority to people crossing the side roads. So as you can see, there's a zebra crossing for pedestrians, and there's a cycle track with give way markings. And the whole geometry is designed so that vehicles are placed perpendicular to that crossing so they can see the people crossing, and the people see the crossing can see them. There's also a lot of initiatives to reduce speed limits in residential areas. That's from the 20's Plenty campaign, and in London now there's quite a widespread movement to make 20 the default speed in residential streets. And finally, there's this idea of shared space, which has been trialled quite a lot in parts of Europe. And the idea is that actually we move away from priorities, that actually drivers ought to be perfectly capable of sharing space with people who are on foot. We're all human beings. And so you take away a lot of the dividing lines, and the drivers go at a slower speed that enables them to pass and make eye contact, to negotiate for the space. And now there is a downside with that. There's a lot of concern with people with impaired vision in particular, for very understandable reasons. But again, when we get to autonomous vehicles, maybe that will help deal with some of those problems. So let's look at AVs then. Where do they fit into this? Apologies for having more text here, but what I wanted to do was to try to capture what are the pros and cons of AVs in terms of integrated transport and their wider role in society. So one obvious benefit from having an autonomous vehicle, and one that I really appreciate myself, is not having to worry about the parking. It drops you off, it picks you up at the door and drops you off at your destination, which means it's a lot more convenient for the user, means there's a whole lot of parking space that we can reallocate to something more useful. And at stations, that might be shifting it to pick up and drop off spaces, or cycle parking, or bus interchanges. Other streets, residential streets, we can shift it over to walking or cycling, or we can actually narrow the carriageway, plant trees, we can improve the urban environment. The downside of that, of course, is that not being able to park is a major reason why people don't drive and why they take the train into the centre of London, for example. So if you remove that barrier of not having to worry about a parking space, you might well have a lot more people wanting to drive, which would be counterproductive. Similarly, the benefit, not having to drive in difficult traffic, something I personally very much like. I don't particularly like driving. I think it'd be great. And there's a further benefit that for people who currently can't drive, people who are not able to drive for medical reasons or whatever, opens up a whole lot of opportunities for accessibility. The downside, of course, is we might start shifting people onto cars who currently take public transport, or walk or cycle. Something that is autonomous is inherently linked to things like apps and journey planners and so on. It's ideal for that purpose, which means that it provides a really good linkage potentially into public transport. So that big barrier that I was talking about earlier to interchange is greatly reduced. If you could book something that turns up outside your door at the appointed time, and you don't have to worry, are you going to miss your connection, because the system will be more reliable. So there's a great benefit there of getting more people shifting their longer journeys onto public transport. Downside, of course, it might displace walking and cycling for shorter trips. And this final point, and I will come back to that in a bit, but I won't take too long, I promise. Historically, control over, so the imposition of speed limits and access restraints and parking restraints, it's all been done on the basis of what will drivers put up with as distinct from what is actually required for the site. AV gives you the ability to make that decision on the basis of need and to enforce it fully, which gives you potentially the advantage of much safer roads and much more priority and space for vulnerable road users. The other side to that coin is, might it lead to people wanting to impose more restrictions on pedestrians so that you can create more capacity for vehicles? I'll come back to that in a minute. In terms of the positive side, this is from a project that we are doing that's funded by Innovate UK called Merge. It's some modelling of origins and destinations in the Greenwich area, and that was showing opportunities for ride sharing by AV that could actually pick up quite a lot of people. So that's the positive side here. If we look at the traffic and streetscape implications, however, and apologies for the text again, but there's some quite fundamental questions. There's an assumption here that AVs will be used on roads that basically function in the same way as they do now. However, we will now have perfect enforcement, if we like. Let's consider the situation where the technology has improved to the point where pedestrians can be confident that they won't be run over. The vehicles will be more risk-averse. How will people respond? Will they wait for crossings? Will they take a long detour as they are now? Will they not cross? Which leads us, this is the last one I promise, which leads us to two possible scenarios as to where this might go, which I'd like people to think about. There's a kind of cooperative coexistence where AVs detect pedestrians, they share the space, they operate at relatively low speeds, no one gets run over, it makes shared space work. They serve primarily over shorter distances to serve other modes of transport. Or there's this exclusive kind of model that says, if pedestrians are going to keep being annoying and keep crossing the road and stopping the vehicles, we better ban them, we better bring in like the horrible idea of jaywalking that they have in America. We'll have more barriers and more restrictions and actually exclude that and have more people in AVs and thus worse congestion. So those are two possible visions here, and I think we have to think about that now, because even though, as Ray pointed out, it's a long way in the future, it's still time to be thinking about it now. So thank you very much.